3.0 Mole Concept Part 1 First Hour 3.1 Avogadro Number and Molar Mass. Learning Outcomes. Define mole in terms of mass of carbon-12, Avogadro's constant. Relate Avogadro's number with molar mass and molar volume of gas at room condition and standard temperature pressure. Introduction. The atom's molecules or formula units are the entities that react with one another. So, we would like to know the numbers of them that we mix together. But how can we possibly count entities that are so small? To do this, chemists have devised a unit called the mole to count chemical entities by weighing them. Mole. 1 mole is the quantity of a substance that contains the same number of elementary entities, which is atoms, molecules, ions, as there are atoms in exactly 12 grams of carbon-12. 12 grams of carbon-12 contain 6.02 times 10 to the power of 23 carbon-12 atoms. 1 mole of any particles contain 6.02 times 10 to the power of 23 particles. This is Avogadro constant. The term mole, just like a pair or dozen, refers to a particular number of things. 1 pair equal to 2, 1 dozen equal to 12, and 1 mole equal to 6.02 times 10 to the power of 23, which is the Avogadro constant. The number of atoms in a 12-gram sample of carbon-12 is called the Avogadro constant. For example, 1 mole of sodium metal contains 6.02 times 10 to the power of 23 sodium atoms. 1 mole of chlorine gas contains 6.02 times 10 to the power of 23 chlorine molecules. 2 times 6.02 times 10 to the power of 23 chlorine atoms. 1 mole of calcium bromide contains 6.02 times 10 to the power of 23 calcium bromide formula units. 6.02 times 10 to the power of 23 calcium ions. And 2 times 6.02 times 10 to the power of 23 bromide ions. Formula to calculate moles is equal to number of atoms or molecules divided by Avogadro constant. Okay, let's count the number of atoms or molecules. Example of questions. A. How many atoms are there in 0.8 mole of copper? B. How many moles of chlorine molecules in 8 times 10 to the power of 22 molecules of chlorine gas? Okay, for the solution, use the formula to calculate moles. Insert all the value given from the question. 0.8 mole copper equal to number of copper atom and divide by the Avogadro constant. So the answer is 4.82 times 10 to the power of 23 atoms. Okay, now let's count the number of mole of chlorine molecules. Insert the value given from the question. Number of molecules divided by Avogadro constant. So the answer is 1.3 times 10 to the power of -1 mole of chlorine molecules. Or you can use the alternative with as shown.